In this screencast, you're going to learn how to draw the derivative of a polynomial without seeing the actual equation. Step 1 into doing this is determining the highest power of the original function. In order to do that, you count how many times the slope changes. So in this case, for the example to the left, you have a positive slope, a negative slope, a positive slope, a negative slope, and another positive slope. And you just count how many times, which I did here, and it comes out to be 5. So the highest exponent you have in this equation is x to the 5th. Step 2 is you're going to find where the original equation has a slope of 0, or how many times it does that. And what I did on the right is I drew a line where the slope equals 0 each time, and I plotted it back to the x-axis. So I had a point here where the slope equals 0, and I just plotted it back down to the x-axis as I did with these other 3 points. And what this tells you is that the derivative of this function is going to cross the x-axis 4 times through those points. Step 3 is determining the highest power of your first derivative using the power rule. The original function had the highest power of x to the 5th, so you can take the product rule, which is your exponent times your leading coefficient, which is 1, so you have 5 times 1, x, minus 1 from your exponent, so you have 5x to the 4th power. In this particular case, though, you don't need the leading coefficient, you just need to worry about your exponent, which is 4. And the exponent tells you how many times the function, or your derivative, is going to curve. In this case, it's going to curve 4 times. Step 4 is determining the slopes of each curve of your derivative. In order to do this, you look at your original function and determine whether the slope of each curve is positive or negative, which I did here. You have a positive slope, a negative slope, a positive slope, a negative slope, and a positive slope. If the slope is positive, the start of the curve is going to be above the x-axis. If the slope is negative, it will be below the x-axis. And everywhere where the slope equals 0 on the original equation would be the point that we plotted, and the derivative must go through those points. So since this is positive, it starts in the positive range, and it starts to go negative because it goes negative down here, all the way to here, and it goes back up to positive because this is a positive slope, and then it goes down to negative, which is down to this point, and then it starts going positive again all the way up to it doesn't change anymore after that.